In this video, we'll learn about the chain rule. Now, the chain rule can be really tricky to write down, but it's best understood through doing a few examples. Basically, what it lets us do is differentiate composite functions. And what composite functions normally look like is, well, we start off with like a normal function like this, and we do something to that function like squaring it. And you can see some more complicated examples like here, we've got this complicated function here, and then we're taking the square root of it. It's when you kind of do two different things. Okay, so let's find this derivative the traditional way by expanding and simplifying first. So our function is going to equal, now I will be using a plus b squared equals a squared plus 2ab plus b squared. And this is how we have to approach it before we've ever learned the chain rule. So this is 25x squared, because you square the 5 and the x. Yeah, that middle term is going to be 2 times 5 times 3, which is 30x. And then that last term is going to be 3 squared, which is 9. Now if I actually differentiate it, I'm going to get 25 times 2, so 50x plus 30. Okay, so that wasn't too bad, but the power was pretty low. It was only 2. And what we'll see later is we can differentiate much higher powers using the chain rule. But let's just use the chain rule on this and see what happens. So our original function is f of x equals 5x plus 3 squared. And you do a couple things. So basically what you'll do is you're going to do your standard derivative. So if we've got this stuff to a power, the power will come out the front and drop by 1. So the powers come out the front and drop by 1, which is pretty standard differentiation rules. Only thing is, then you times by the derivative of what was inside the brackets. Some people like to call that the baby. So let's do that. So we've got our function here, 5x plus 3 squared. The 2 is going to come out the front, just like that. So f dash of x is 2 lots of 5x plus 3 squared. Not squared, to the power of 1. So the 2's come out the front, the power's dropped by 1. That's what we get. Now, we have to times by the derivative of the stuff inside here. What's the derivative of all that? Well, it's 5. Okay, so let's see what we get. This is going to be 2 times 5 out the front, 10 lots of 5x plus 3. Cool. So does that match the original derivative we got? Not quite, but it will if I expand it. That's 50x plus 30. So we are very happy. We've matched the chain rule with the original working out. So you might be wondering, because we can do it both ways and the chain rule looked harder, what's the point? Well, the point is when you get bigger powers like this, you're going to have to use some Pascal's triangle shenanigans to expand that, and you just don't want to do that. So let's just do the derivative of this. I'm just going to call this y equals x cubed plus 1 to the 5. Then our derivative to y dx. Let's see what happens. So the 5 comes out the front. And I've got 5 bracket x cubed plus 1 to the power of 4. What do I need to do? I need to times it by the baby. So the derivative of the stuff inside here is going to be 3x squared. Good stuff. Okay, so let's simplify this down. 5 times 3 out the front gives us 15. And I'm going to pull the x squared out the front just to make it all uniform and normal. Then we've got x cubed plus 1 to the 4 still. And that's about as simple as you're going to get. You can do some expanding and stuff, but the whole point we did this was to avoid expanding. So let's just leave it like this. Now, you could have in theory done that derivative by expanding out and just doing your normal rules, but this next one we'll see is impossible without the chain rule. So let's call this f of x equals this function. And we know we can rewrite square roots as powers of a half. So there we go, just like that. To get our derivative, we're going to use the chain rule. So the power of a half will come out the front. X squared plus 2x plus 1, the power of minus a half. And we're going to times it by the baby, which is 2x plus 2. Okay, so if you want to simplify this down, let's think about what we have on the top. We have a 1 on the top, and we have a 2x plus 2 on the top. On the bottom of the fraction, we get this 2, and this stuff down here becomes square root of x squared plus 2x plus 1. Now, the reason it's on the bottom is because you get a negative power, and the reason it's the square root is because that power is a half. You can get a little bit fancy here, and you can halve the top and the bottom. And then you can end up with x plus 1 over root of x squared plus 2x plus 1. But I would still be marking both these as correct answers because they're both correct. Actually, I'd even be marking that as a correct answer, and quite often SACE wouldn't even need you to simplify it. But sometimes you do need to simplify it if you're in a multi-step problem and you want a simpler derivative to be working with. Now, I'll stress the chain rule isn't just brackets to powers. It is a whole bunch of other functions. We just haven't learnt those yet. So we will be dipping into the general form later on. But for now, all you need to do is this special case for powers, which is you do the standard rule to your bracket and then you times by the baby. That's it.